Hi parents, it's Miss Thompson. I wanted to send this video your way to help you understand what we've been doing in math class with division. I know a lot of you have been supporting your kids at home. Thank you very much for that. I know that division can be challenging for the students, and I've been working with them in class every day. This chapter is very interesting because it's just a lot of practice with division, because once they understand it, we can make sure that it gets ingrained and they can practice it a lot. Today we work with finding times when there might be a zero in your quotient and recognizing that you need to actually hold that place with a zero. The last lesson we're going to be working on is estimating and rounding to see if our answers are reasonable. That's one thing we've definitely been working on, is the students recognizing if their answers are reasonable. So I'm going to show you the three ways that we have worked with division methods. There's three ways kids can divide. This first way that you're looking at on the screen is called the place value sections method. And I know a lot of you are like, what is this rectangle all about? I'll explain this way and see if it makes sense to you. It makes sense to some of your kids. I still have 7 kids using this method, and it makes sense to them. Trying to teach them the standard algorithm or the expanded notation gets them very confused. This gets them the right answer, and they understand how to do this, so I encourage them to keep doing this method. By next year, I'm sure that standard algorithm will come to them very quickly. Right now, developmentally, they may not be ready to quite grasp the concept of digit by digit division. So this is called place value sections. You can see that there are 3 sections for this one. Sometimes there might be 4 sections. So you have a hundreds place, a tens place, and a ones place written above the rectangle. The number we're dividing is 4,392. We're going to divide that by 5. So we don't need a thousands place, because 5 times even 1,000 is 5,000. It's too big. So the kids know we have to start in the hundreds. So we're looking 5 times 100, 200, 300, 400, 500, 600, 700, 800, or 900. So they start testing those to see which one is the most accurate. This is where their basic multiplication facts are really still very important, because they need to recognize that 5 times 900 will be 4,500, which is going to be too big. So they know that they need to put an 8 here for 5 times 800, which would be 4,000. They would subtract that away from the 4,300. And this tool is nice because I can just drag down my symbols that I need to use, do my subtraction, and I would have 392 left. Now, obviously, your students are writing this either on their math boards in class or in their books. Now I take the 392 over to this section, the tens section, and I begin asking myself again, 5 times 10, 20, 30, 40, 50, 60, 70, 80, or 90. 5 times 70 is 350. 5 times 80 is going to be too high, so I know I need to do 5 times 70 for an answer of 350. And again, I subtract that away from 392. And we get 42 left over. And again, we take that 42 and we put it in the ones place. Now they can clearly see 5 times 8 would be 40. They take that away from 42, and you can see that they're going to have a remainder of 2. And their answer is clearly written for them across the top of the box. The answer to dividing 4,392 by 5 is 878 with a remainder of 2. Here is their answer written right across here in place value. So they can see there's 800, there's 70, and there's 8. So 878 remainder 2. That's place value sections. That works for any size number. They know that they have to decide, do I need a 3-box section? Do I need a thousands section out here, depending on what my divisor is? The next way I'm going to show you is called expanded notation method. And again, some students are using this. They like this. It makes sense to them. So again, they keep doing it to get the right answers. It's the same problem. So that'll help us to save some time. We know that 5 times, and again, this is place value sections without the drawing, without the rectangle. So we're just going to expand out our place values. That's why it's called expanded notation. So we're going to start with our hundreds place. 5 times what hundreds will get me close to 4,392. We know that it's 5 times, where am I at, 800 is 4,000. I'm going to take that away from 4,392. And I'm going to get an answer of 392. Just like I did in my first one. This looks more like the standard algorithm, but it's combining both place value sections and the standard algorithm. Now above my 800, I'm now going to do, since I've done my hundreds place, I now want to do my tens place. So I'm asking myself 5 times how many tens is going to get me close to 392. And we know that that's going to be 70 tens, or 7 tens, sorry, for an answer of 70. 5 times 70 is 350. Take that away from 392. And we'll have that 42 left over again. Five times ones, we've done our hundreds, tens, now we're going to do our ones. 5 times 8 is 40. Oops. Take that away from the 8, or from the 42, and we will have an answer again with a remainder of 2. So our answer is now at the top of the page. Same thing, 878, and up here we put our remainder 2. So the kids can again clearly see that the answer is in, again, expanded notation, because we expanded out 878 to be 800 plus 70 plus 8 with a remainder of 2. So I have some students doing this method. They like it. They've gotten this far. They're comfortable. And then, yes, we've gone on to the standard algorithm, where the kids are using terms like long division, or I know they're used to the old-fashioned method, the way my parents did it. So we are looking at the standard algorithm. In the book, it calls it digit by digit, because that's literally what we're going to do. We're going to multiply these numbers digit by digit. And I'm going to switch to my pen so it can go a little quicker with digit by digit. So we're asking ourselves, how many groups of 5 can I get out of 4? And my answer is 0. Yep, my pen's not going to work. And then we're going to put a 0 down here. Take that away from the 4, as you and I do. And we still have 4 left over. And then I taught them that they have to bring down. You may notice that they're drawing arrows. Excuse me. They're drawing arrows of the next number that needs to come down, but the next number that needs to come down is a 4 or a 3. Before they do that, this is where they're making their mistake. They're not checking their subtraction, because the number left over from their subtraction needs to be less than their divisor. Today, kids were getting an answer of 7 there, and then trying to go on, and then they have a 73, and 5 times what is 73? It's going to be a 2-digit number. So we have to check to make sure that this answer in our subtraction is smaller than our divisor. All right, bring down the 3. 5 times 8 is 40. And we're working on lining them up above the place value. 5 times 8 is 40. Take that away from 43. We have a 3 left over. And again, check to make sure that 3 is smaller than my divisor. If it's bigger than a 5, I could have gotten another group of 5 out of that number. Now we bring down this 9 all the way down. 39. 5 times what gets me close to 39? The answer is going to be 7. 5 times 7 is 35. We take that away from 39. And we have a 4 left over. and that's good because it is smaller than our divisor. We have one more number to bring down, which is a 2. 5 times what will get me close to 42? 5 times 8. And you can see we're building the same exact answer that we did in the other two methods. And we will have 40 left over, or 40, we'll have 40 with 2 left over when we do our subtraction. We have 2 left over, so we go up to our quotient, and we put remainder 2. So all 3 methods get you the same answer. All 3 methods work. It's just a question of where your child's brain is at this point. So let's go back and review place value sections. Rectangle, the kids divide the number into place value sections, dividing by the hundreds first, then the tens, then the ones, possibly starting in the thousands if they need to. And then the expanded notation method makes sense to students. They think 5 times 800, take that away from the large number, then go to my tens, multiply that, take that away from the number, go to our ones, okay, and then digit by digit is the way that you and I understand for doing division, and the book calls it digit by digit. So we do have a test on Tuesday, and I want the kids to look at all the different ways and try the method that works best for them. I did move some students from the place value sections method to the standard algorithm because they're safer with their basic facts when it's single digits, or in this case double digits. But when they're talking about 5 times 800 or 5 times 400, sometimes they're not grasping that that's 2,000. So I did ask them to try and go to the digit by digit method. So today we worked with those quotients in the answer. Oh my goodness, the zeros in the quotients. So we have to watch when there might be a 0 right here in the tens place or a 0 here in the hundreds place, that we make sure we record that 0 to hold that place. If we don't do that, we get a different answer, an incorrect answer. So here's that's a short video on how I've been teaching the students at school, and I appreciate your help. Maybe this will help you understand and help them practice for the weekend. And let me know if you have any questions. Thanks.